Hello, AP Calculus students. It's Mr. Ford here in the home studio once again, and this is the last topic of our summer packet for AP Calculus, the transition period from being a pre-calculus or an Algebra 2 student into AP Calculus, and the things you need to know to be successful in this class, just getting the expectations right. As you can see, it is summertime, but we are in the studio today because it's nice and cool down here. It's 90 degrees outside today while I'm recording this. But today, this is the only video of this series in which you're going to require some specialized equipment. Now, you might notice down below, I've got calculator cam all ready to go, and we are certainly going to talk about that a lot. Now, I'm going to make two versions of this video, and the version you're watching right now is the version on how to solve all these problems with the TI-84 calculator. So mine is right here in front of me. If you do not own one of these calculators, I have a classroom set, so you can borrow one from me for the year. You can check one out at the beginning of the year. I have enough for my Algebra 1 students that you can just have it. As long as you give it back to me at the end of the year, we're good. It's a good idea. If you are planning to pursue a degree in college or in science or math or computer science, it would be a good idea to invest in one of these. They're usually in the $100 range somewhere. The 84 has been the industry standard for a long time. The Inspire has made a lot of waves in changing that. A lot of calculus classes will have a classroom set of Inspires. But also there's a big movement happening right now in the calculus world to go away from calculators entirely. I think what you'll notice in a lot of what we do in this class is that you don't need a calculator for most of it. And over half of your AP Calculus test is calculator free anyway. But the only thing that delineates a calculator question from a non-calculator question on the AP test is you must know how to use this device to get answers really fast that could not be expected to get otherwise by hand, and that's exactly what we're going to talk about today. Now, if you're looking at the packet that I gave you or that you grabbed before summer or you downloaded off of Google Classroom, you can find this kind of brief introduction to how to do the things we're going to do in this video. I'm going to walk through these steps on all the examples that we're going to do. Remember, this video is for the TI-84 calculator. I'm also going to make a second video for this that uses only Desmos to solve this question, which is also a viable tool. The only reason why Desmos might not be the best option for you is that it is not allowed on the AP test. You can't bring a laptop into that test or your phone. Although Desmos is, I think, a superior tool when it comes to learning conceptually what's going on. The 84 is a handheld, does everything in one spot. It's a great tool also. So that's enough talking. Let's get all that out of the way. Let's go ahead and talk about the questions that you should, again, there's that word, but things that you want to be able to do on your calculator quickly without really hesitating. So let's talk about the first thing. What we're going to do is we're going to find the zeros of the following functions. Now, we've certainly found zeros before in this series, but these equations that we're dealing with here, you could not factor these nicely. If I'm looking at number 1, for example, 3x to the third minus x minus 5, there is nothing that factors out of this. If maybe there is, I don't know. You could do that whole thing where, I know it has to be a 3x in the front and a 5 at the end, and you could guess and check and do long division and maybe find 1 or 2 factors, but this would be an extraordinarily difficult thing to do by hand without a calculator. However, since we have an equation that equals 0, what we're going to do is we're going to use a really standard practice, which is what we're going to do is step 1, we're going to graph the function. We're going to graph 3x squared minus x minus 5. And number 2, we're going to see where it equals 0. In other words, where it crosses the x-axis. This is a great process that, by the way, always works for any problem. This is the thing I teach my Algebra 1 students to do, and I go, you can use this for the rest of your math career, for the rest of your life. If you know how to use a calculator, you can get around a lot of stuff. Now, let's talk about how to do this on the calculator. So I'm going to walk through this as if you have never seen an 84 in your life. That might be the case. Maybe you don't know how to do some of this stuff. Maybe just walking through, you might pick up a few things. So this video might move at a slow pace if you're kind of excited about it. So try to skip around. Also, since it's a recorded video, you can go back and watch things over again. So if you miss a step or blank out while I'm explaining something, you can always just reverse it and watch it again. So here we go. First of all, we're going to turn our calculator on. Now, a little bit of a note for this calculator. I am going to have to turn, I'm trying to adjust my microphone here, because I'm going to have to move my body a little bit to be kind of in this position, which is perfect. I'm actually going to make calculator cam a little bigger, because there's actually not a lot of work to do on this video. The answer I'm just going to write down when I'm all done. Okay, for the first things we got to do, let me turn this lamp on this thing here. Is there a light on this? Perfect. Oh, much better. Okay, a little thing. All right, the first thing we should notice is there is a button that has the word mode written on it right next to the second key, right there. You're going to want to press that button, and if you are in AP Calculus right now, you're going to want to make sure that Radian is selected and never change it. The AP Calculus test in College Board does not use degrees in any way, so keep your calculator on Radian forever. And if you ever borrow a calculator from me, the first thing you do, make sure it's switched over to radians, because we never use degrees in AP Calculus. This doesn't apply to this question, but it's worth noting right away. Also, probably a good idea to just make sure that everything in here looks normal. If your calculator ever acts wonky or does something weird, there's a good chance that a freshman that got a hold of it was just playing with things in the menu. So anyway, we're going to start by pushing the Y equals button. We want to graph things, and we do that with the Y equals button right there. And this calculator can handle up to 10 inputs. Here they are, Y1 all the way through Y0 hanging down there. Those are the 10 graphs, so you can graph up to 10 different things on this. We're only going to graph one thing. We're going to grab 3x to the third power minus x minus 5. I'll have a lot of time to talk about calculator tricks that you should just know for success in high school math and science, and even college math and science. The caret key, of course, is the one I use to get the exponent right there. We call that the caret key, C-A-R-A-T. And fortunately, you can put whatever you want in there. That's fine. That looks good. Now, normally, if we wanted to set this equal to something, we might have to graph another line, but we just want to know when it crosses the x-axis. So we're going to go ahead and push graph. Now, we're going to watch the calculator graph this. One advantage that I believe the 83 has over Desmos is that it actually animates the graph from left to right, which I think is a good thing. Here you can see your one solution. I'm going to grab my favorite educational multitasker, a paper clip that is bent into a straight shape here, so I can point at exactly what I'm looking at. That point right there appears to be the answer, somewhere between 1 and 2. Probably 1.18 or something like that. We actually don't know. The calculator can tell us exactly what it is, but it looks like there's only one solution. If you want to get all Algebra 2 or Pre-Calc, that would mean that this graph has one real solution and two imaginary, because it is a third degree polynomial. So it does have 3 solutions, but only one of them is real. So we can see it right there. Anyway, here's where we are going to start the next part of the process. How can we find that 0? Well, we're going to need to access the Calculate menu, which is right above the Trace button. We're going to push second and the Trace key and open up the Calculate menu, and you'll find it right there, option number 2, 0. There you go. Now, your calculator is going to ask you now for 3 prompts. It's going to ask you for the left bound, for the right bound, and for a guess. The guess doesn't really matter so much, but the left bound, you have to move your cursor to the left of where you think the 0 is, so push enter. The 84 nicely draws a little line for you there, so it remembers where you marked it. You want to move your cursor to the right of the 0 and push enter again. And so what the calculator will do is search for a 0 in between there. Since there is only one of them in that range, the guess function doesn't really do anything, but it's nice to get in the habit of putting the cursor as close as possible to that point as you can get it. If you push enter, the calculator will think for a second and then spit out the answer, which we will just write down on our paper, since we do not have to show any work for these kind of problems. 1.279. A couple other notes about the AP Calculus test. Since this series of videos and this packet is technically meant to prepare you for that class, the AP Calculus test requires 3 decimal values beyond the point. Remember that half of your test is free response, properly rounded if you will please. 3 decimals beyond the point, properly rounded for answers. And on a calculator question like this, you are not required to show any work. They know that they're giving you a question that requires the calculator. They know you're going to use your calculator to get the answer. They just care about the answer. That's all they want. So there you go. There's only one solution to this one. Let's try that process again. Oh, and that's a perfect time for my computer to just decide to stop casting. Let me recast here. And we're back in business. Okay, now we got 2x squared minus 1 equals 2 to the x power. Well, this one might be a little more complicated. So here we have 2 sides of a graph. We have 2x squared minus 1 and 2 to the x power. What we're going to do is we're going to program the first one into y1, and we're going to program the second one into y2. And this will draw 2 graphs for us on our screen, and then we will see where they cross, because we want to know when they are equal to each other or the same. Let's go back into our y equals menu. So 2x to the second power. X squared, of course, has its own dedicated button. Right there, kitty corner to the number 7. You could, of course, use the caret key if you want to, but x squared is useful enough on its own. Minus 1. There. And then 2 caret key x. The x button, by the way, is the button right next to the alpha key. It is, we call it the x button. It's got a bunch of other stuff on it, but I have a college degree in math, and I've only ever used t on this. I don't know what theta and n do. I think I know what theta does. I have no idea what n does. So don't worry about those so much. I wish that button just had x on it for high school level. Anyway, what we're going to do now is we're going to push graph. Now, in the event that we don't see anything on this graph, what we might have to do is change the window, which I suspect we'll have to talk about at some point during this video. Actually, now is probably a good point to talk about it before we go on and do our work in this problem. The window button is the unsung hero of graphing functions on your calculator. It's right next to the y equals key. It's right here. This is the word window on it. And what you can do there is you can see, first of all, what window you're looking at. This is what we would call the standard window. -10 to 10 on x with a scale of 1, and -10 to 10 on y with a scale of 1. What that means is that the x-axis, we push our graph, starts at -10 and goes to +10 and counts by 1s. Y-axis starts at -10, goes to 10, counts by 1s. You can manually override any one of these and change it to be whatever you want to. There are also several preset windows in the zoom menu and the third option. The ones we use the most in this class are Z standard, number 6, which is the one we just looked at. There's also Z decimal, which is pretty helpful if your graph is small, and also Z trig, which is goes -2 pi to +2 pi for trigonometric graphs. But okay, back to the task at hand. Now, here we do not want to use the 0 function again because we don't want to know when these graphs equal 0. We want to know when they're equal to each other. So what we wish to know is when do they intersect. So to do that, we're going to use, again, the calculate menu. So push the second and the trace button to open up the calculate menu. And this time, we're not going to choose option 2 because we don't care about option 2. What we care about is option 5, intersect. Where do these two graphs intersect? Again, the calculator is going to ask us for 3 inputs. It's going to ask us for what's the first curve, what's the second curve, and what's your guess on where they cross. The guess actually is important on this one, and I'll tell you why in a second. So first curve is going to default to whatever is in y1. Notice how that's the 2x squared minus 1 parabola that we put in there. So you can go ahead and push enter because your cursor is there. The cursor will now default to whatever is in y2. Since we only graphed 2 things, these first 2 steps you can just push enter 2 times. Sometimes you graph like 4 or 5 graphs and you want to be able to hop between them, in which case you would use the arrow up and arrow down keys. Not super important for this particular problem, but it does pop up from time to time, so we'll push enter. Now it needs a guess, and since there are 2 intersections, there's one right about there and one right about there, we do have to tell the calculator which one we want. So you have to move your cursor onto the one that you are looking for. Let's start with the one on the left. So the calculator will choose that one, and it will calculate this for us. And the answer looks like the first value for x is about negative 0.879, if I'm rounding up correctly. 0.879. Like that, I wrote it down. I have to move my, there we go. There's my answer. We're going to go through those steps one more time to get the second intersection. Second, calculate. We're going to choose option 5. You can just push the 5 button if you're cool. Again, you can just push enter twice for first curve and second curve because there's only 2 curves in there. This time, we're going to move our cursor over here because we do want it to guess the other option, which is apparently 1.323. That's the x value that we care about. We actually don't care about the y value here at all. We just want to know what input gives us an equal output. The output itself we don't actually care about. Again, those are the 2 answers to this question, and there they are. So right away, we tackled 2 big ideas. If you can do these 2 things really fluidly on your calculator, you're going to be in really good shape for this class. The first one was to find when it's equal to 0. Second one is to figure out when they're equal to each other. So we're going to do that same thing for pretty much all the examples here. I'm going to move a little quicker now that we've gone through the basics. See, the difference between these questions, number 3, look at that. Like, this would be ridiculous to solve by hand. I mean, obviously, there is a number for x that might make this true, but how are we even supposed to be expected to even start doing this with algebra steps? And the answer is we're not. This is a calculator question. So let's use the calculator. Let's go into y equals. Let's clear out whatever's there. Let's go ahead and write 2 natural log of, in parentheses, x plus 1. The only really challenge here, make sure you're typing it in exactly correct. We want to know when that's equal to 5 cosine of x. Since we're using a cosine, now is an excellent time to go into your mode menu and just double check, make sure you got it in radians. Since this graph uses, this graph actually gives us a domain to worry about. So let's talk about the window menu for a minute. We're going to push the window button. And we're going to change the x min to 0 and the x max to 2 pi because we really only care about answers that exist on that domain. So let's push the window button and let's do exactly that, 0 to 2 pi. You might notice that as soon as I push enter on 2 pi, it's going to change it to a decimal. That's just what it does. Now, a scale of 1 wouldn't really make much sense when we're counting by 2 pi, so I like pi over 2. Pi divided by 2, just helpful to think about. And for a y min and y max, we're just going to leave those alone. 5 cosine of x has an amplitude of 5, so it will go up to 5 and down to -5. And I think this window will do just fine for that. So let's go ahead and push graph. Again, we get to see the graph animate, which is cool. There's your natural log function doing what logarithms do. Here's your cosine function doing what cosines do. And again, looks like on this range we have 2 answers. One is going to be right there, and the other one's going to be right there. So let's run through the steps. We're going to push second and calculate to open up the calculate menu. We're going to choose option number 5, intersect. We're going to push enter twice since we only have 2 functions programmed in, and we're going to move the cursor onto the leftmost one to get the first answer. And it looks like our first answer is x equals 1.242. I'm going to round that third number up since the fourth number is 9. It is worth mentioning you can put as many numbers as you want beyond the decimal point. The test readers are looking for 3 beyond the decimal point. Calculate, intersect. Once you get the hang of this, it goes real fast. Enter, enter, and then move your cursor all the way over to as close as possible to the one that you're looking for next. Again, you can see how this process can get a little more complicated if we had 3 or more functions on the graph. But with only 2, it's really simple. That's why we suggest you keep it simple. 5.564 is the other answer. Right there. Cool. Okay, let's talk about the next question. Number 4. Use your calculator to find the solution or intersection of the given system of equations. See, look at this. F of x is a quartic function to the 4th power. G of x is some weird E thing. This is a good signal to you, the AP Calculus student, that, I'm just going to grab my calculator and let the calculator do all the heavy lifting here so you don't have to do anything. You're just looking for where these 2 things are the same. And as long as you understand that concept, where the 2 graphs are the same is where they cross, that's all you got to worry about. So let's be very careful here. Again, we're going to cancel out or clear out all our stuff. We got x to the 4th power minus 6.5x squared plus 6x plus 2. Give it a double check, make sure we got it right. The second function is 1 plus x plus e. Okay, so e is interesting. You have 2 separate places where you can find e on your calculator. They're both second commands. I guess it's probably worth mentioning. I didn't talk about it at the beginning of this video, but the second button in blue here, what that does is when you push the second button, what it does is it puts a little arrow on your screen. You can kind of see it right there. I'm making it very, it doesn't help at all. Turns your cursor into a little up arrow. What that means to you is the next button you push will not do what's on the button, but the blue text above it. So if I'm looking for E, for example, which is the second command of the division sign, you can barely make it out on this. If I want to say that, I have to push second and then the divide sign. Another option is to push second and then natural log, which has e to the x power. Saves you 1 step, maybe 0.5 seconds. It's up to you. Anyway, e to the x squared minus 2x. Right there. I'm full of calculator advice if you ever want to talk calculator stuff. I'm just going to make sure, I'm going to arrow up to this. I'm just going to make sure that I got this in parentheses. Just because I want to make sure it's got it in parentheses. Okay, this feels pretty good. Now, if I push graph on this, remember that we already isolated our domain from 0 to 2 pi. So there's a good chance we won't see anything on this graph. Since this window is not showing us the whole picture, we might see something. Well, we got 1. But we probably want to see the whole thing. So a good shortcut for this, you can go into the window menu and you can manually change the numbers that we changed earlier, or you can push the zoom key and then select option 6 from this menu, which takes you back to that standard negative 10 to 10 graph, which is what most graphs will use. You'll be pretty good in school with those ones. Oh, it's be real time. This is like the third one of these videos where I've had a be real in the middle of it. Sorry, I'm going to pause this for a minute. Got to do it. Okay, cool. Had to. Now, it looks like, if I'm looking at this graph correctly, it looks like we have 3 intersections. And I'm actually going to change the window one more time. I'm going to push the zoom key, and I'm going to use Z decimal, which has a very similar window. It's very standard. This one goes from like -5 to 5. So we'll get a better look at the graph. It just zooms it in a little bit. There is our second part to this. It's just barely off the screen. Zoom decimal goes from -6.6 to 6.6 on X, and -4.1 to 4.1 on Y. It does make a perfect square graph now. The X's and Y's have equal value, which is cool if you're into that kind of thing. Anyway, we're going to do the same process as before. We're just going to go to second calculate. We're going to choose option 5. We're going to push enter twice. And the first one looks like it's right there at 0.2. That's a pretty good one. So the first option is X equals 0, which is a quick spot check. We'll confirm that's going to work. Yes, plugging in 0 for X gives you, in this first question, these all cancel out and you're just left with 2. In the second question, you get 1 plus 0 plus 1, since e to the 0 power is 1. So 0.2 is a part of this system. That's cool. Okay, let's do the next one. Second calculate, option 5, enter, enter. This time we're going to move our cursor onto the second intersection right there. Looks like it is 1.033 if I'm rounding up. And the final one, again, second calculate, option 5, enter, enter. Move our cursor up there, push enter one more time. Looks like the last one is, 2.4, X equals 2. Oh, I suppose that works. I mean, I believe him, so it has to work. Pretty good. Not so bad. Honestly, these equations look like they're absolutely bonkers, and trust me, they are. What the key here is, it's not anything to do with dealing with the equation. We're going to let the calculator deal with the equation. Let's talk about another thing we got to do, is relative maximums and relative minimums of the point on a given function. That's exactly. Oh, is this the last question? Okay, good, cool. So relative maximums, relative minimums. So this one, what we're going to do is we're going to go once again into the calculate menu, but we're going to use a function we haven't used yet. But let's first of all go into y equals. Let's clear out everything we've used so far, and let's go ahead and program in this function: 2x to the 5th power, nice polynomial, minus 3x to the 4th, plus x minus 4. Just like that. Nice, smooth, basic, boring polynomial. No problems at all there. I'm going to go ahead and push zoom and then select number 6 before I graph, because I'm pretty sure I'm going to need to go back to the standard graph to see it. Give it a second to think. There we go. Okay. Now we are asked in this problem for the relative maximum and relative minimum of this function. That is the task. Now, if you're looking at the graph, if you know those phrases, I mean, even if you don't know what those mean, I'm pretty sure you can guess what they are. They're pretty basic. This graph kind of looks like this. It comes up, does a quick turnaround, goes down, turns around again, goes back up like this. So this point right there, that point is what we call the relative maximum. Now, the reason why it's a relative maximum and not just the maximum is because this graph goes forever up. So there's lots of points that are bigger than that later on. But in that little small isolated area, it is the highest point. It is the top of a hill. The same thing is true about this point right there. I would call that a relative minimum. Relative minimum. Because, again, it's not the lowest point, but it is the lowest point on that little slice of life there. So that's something to think about. We do a lot of stuff with minima and maxima in this class. Anyway, let's talk about how to do them. We're going to once again jump into the calculate menu, which, just as before, is located on the second command of the trace button. So push second and trace, and you'll open up your calculate menu. And, you know, the old adage about if you don't know how to do something on a computer program, just click around until you see it. There it is right there, minimum and maximum. Let's do the maximum first, since it happens first. Now, the calculator, again, is going to ask us for 3 inputs. It's going to ask for a left bound and a right bound. Actually, I don't know if it gives us a guess. Let's find out. We just need to make sure we move the cursor to the left of the maximum and then move it to the right of the maximum. Oh, it does ask for a guess. So let's go ahead and put the cursor on top of the hill there. The guess doesn't really do anything in this case because, again, there's only one of them, but the calculator will now search for the biggest y value in that point or in that little domain we gave it, and it will spit out the answer. Looks like our maximum, or our relative maximum, is at 0.53. Now, since we are actually looking for the relative maximum, we're actually going to give the ordered pair. So this is the only problem today that does require the y value. Oh, sorry. Let's do maximum first. So the relative maximum happens at the point. The x value is 0.531 if we're rounding up. And the y value is negative 3.623. We don't need to round there because the number is 0 on the end. There you go. Now we do want the whole ordered pair. There's a big lesson about this we'll talk about in calculus when we get to the class, but this is where the max is, and this is what the max is. Now, those are not always the same question. That's the thing we got to talk about a lot in calculus, is a lot of times, because most of the problems that you will solve on your AP Calculus test are story problems. And they will ask for a specific thing, and it's all about interpreting what they're looking for. So the x value is where it happens, but the y value is what it actually is. Those are not the same thing. But here, they just asked for it, so we're going to give the general answer. Again, for the minimum, we're going to push to second and calculate, and we're going to choose minimum from the list this time, option 3. We are going to go ahead and push enter to the left of the minimum, move our cursor to the right, and push enter again. And once more, we'll put our cursor kind of on the bottom of that hill. We'll push enter one more time. The calculator will spit out what the minimum is. There's a lot of math happening there. Again, for you to do this by hand would be silly, but the calculator can do it in an instant. So let's just ask the calculator. Looks like it's 1.131 and negative 4.077. Again, since the number 5 there is 5 or more, we're going to round it up to 7 right there. So we got to review rounding stuff there. And there you go. There's your relative minimum. Again, those are not the minimum or the maximum, the global or absolute minimums, but they are a turnaround point for the graph. There you go. Let me get the calculator cam out of the way for a minute. And make sure we hit everything. I think that was all we had to do on this, was just those 5 problems. I don't see anything else here, which is great. So to review, we kind of learned, we went through 3 big ideas. Number 1 is how to find things by finding zeros. You got to be able to find zeros. Number 2, 3, and 4 are all about using the intersect feature on your calculator. And number 5 was all about minimums and maximums. Very cool. If you can master how to use this tool, this TI-83, TI-84 calculator, your high school and college years will come much easier to you, my friends, because this thing can do a lot of stuff that you might conceptually understand, but you don't have the ability, pencil and paper, to like muscle out what the minimums and maximums of these freaking equations are. But this thing can do it in a heartbeat. So use your tools appropriately. That's a mathematics standard, my guys. Hey, if you're here and you're watching this video, you made it. You made it through the summer packet, and you have the rest of your time to relax and do whatever you like with your summertime. Hopefully you're being productive in some way, whether it's reading a book or exercising, or I don't even know. Maybe you're playing a sport. Maybe you're watching a movie. I don't know. Maybe you have a job. All those things are great. Hey, I can't wait to work with you in the fall on AP Calculus. This is going to be a great class. It's going to be a great year. I can't wait. It's going to be so much fun. So thanks for watching this series of videos. I will post a second video on this one on how to use everything in Desmos. That's coming up next. And other than that, I will see you in the fall. And have a great summer. And I'm very proud of you for making it this far. You're going to do great. You got it. I'll see you in the fall or in the next video.